Similar to the move command, we can also use basic math instructions to not only do the math function, but also move the result into a designated variable. For example, if I place an empty box and type add, this is a add instruction. You'll notice that we have this auto selector here. And if I click the drop down, all of the different numerical data types that add can accept. There are actually more that it can accept, but it uses something called implicit conversion, and we'll come on to that later. I can either leave this as auto, or if I already know the data type that I'm going to be using, I can set it from the drop down. However, in most cases, you will leave it as auto. In here, I might type a constant, such as 20, and you'll notice that it's red, and it's red because I haven't selected a data type yet. And although TIA-Portal does know that this will be a number, if I look at this list again, an int or a dint or a uint, 20 could belong to any one of those data types. So we can't sort of decide what that's going to be with a constant. However, when I type in my numbers and choose I1 here, this is already defined as an integer or an int. So when I click it and accept that, you can see that auto updates to int, and it will assume that our 20 that we're typing here is also a integer. And then on the output here, if I go and type numbers I2, this means that we will bring in 20 and whatever value is on I1, add them together, and then output on I2. So let's have a look at this running in the PLC. And we can see that we have 20 plus 1, and the value of 21 is now assigned to I2. And this works the same way for nearly all of the basic maths functions. So here I've added a subtract, multiply, and divide. And you can see they all look nearly identical, except for sub and divide do not have this little star that multiply and add have. And effectively, all this allows us to do is to keep expanding the interface of this add instruction or multiply instruction such that it will add up all of them, effectively becoming a summate instruction. And multiply does the same thing, where we can continue increasing the amount of inputs that we can put in to multiply multiple things together. But we can't do that with subtract or divide because the order in which they're put into the system or into the instruction matters too greatly to just allow us to increase the number of inputs on the front of the interface. Well, that's what I believe is the reason. I'm not quite sure why Siemens couldn't do it with subtract, to be honest, but I do kind of understand the reasoning why you can't do it with divide. And for those that are eagle-eyed and are looking at the actual values that these instructions are outputting, you'll notice that 20 plus 1 is 21, 21 minus 1 is 20. Down here we have 2 multiplied by 20, which is 40, and then we have I3, which is 20, divided by 3, which is not 6. And the reason why we are seeing the value of 6 is all down to the data type. So if I hover over this, we can see that it's an integer, and an integer is a whole number. 20 divided by 3 is actually 6.66. And effectively, we're losing that precision because the data type integer can only accept a whole value. Now, this might behave slightly different in different PLCs and in different environments, and we might even find that it behaves differently in individual CPUs, depending on what type of CPU you have and where it's being executed. I believe in Siemens TIA-Portal, we will just lose the precision, so it gets truncated. There's no rounding that happens or anything like that, but in other PLCs, you might find that the number is actually rounded, depending on how they manage the numbers behind the scenes. But because this is an integer, there was never any floating point precision anyway. So that's why we're seeing 6 and we're not seeing it rounded to 7. And that can catch some people out if they're expecting to rely on rounding, because that's not going to happen in this case. And that's it for the basic sort of maths approach. You can see that very similar to a function block, inputs, the actual addition or maths happens inside the instruction, and then the value is passed to your output.